Yeah, so I will talk about the world of site isolation and compromised renderer. Yeah, my name is Jun. I work at Microsoft Edge browser security, basically. So yeah, till last year I was personally bug hunter for Chrome, but now Edge moved to Chromium-based browser, so now I'm no longer allowed to do personal bug hunting on Chrome. I do it as a work, and I need to do donation for all bounty I get. So this year I donated 51K, which is huge money, probably. So I needed to find another way to get money, right? I mean, of course I get salary, but yeah, my wife complains basically. Okay, where was that money goes? Suddenly, like you are earning like 50K a year from Chrome, and where does it go? Yeah, I donate. People, people likes it, but she don't like it. Thank you. It's not my choice, my company's choice. Yeah, so I found some way to earn money from Google VRP instead of Chrome VRP because I can still get bounty from Google VRP. So I got from 124 last year to 35, which I will also talk. So agenda is what is compromised render process and why it matters. Site isolation, I actually talked about site isolation last year, so I'm not going to talk long. But just a recap, and then some bypass in the browser, and then I will also talk about bypass that browser can't fix, and also I will give examples. So compromise render process is basically like, so render process loads a lot of things like JavaScript, CSS, image, video, audio, etc. And so why they load in render process? Because those things has a lot of bug, and you browser first want to make sure that all the bugs are in renderer, so that browser process that runs out of sandbox does not have many bugs. So that's why they render those things and try to pass those things inside the render process, which is in sandbox. But if there is a bug, render process can be compromised. And once it's compromised, you can read any data inside the process, or you can spoof the IPC message that is going from render process to browser process. So you can do something. And this means if you don't have site isolation, this means basically UXSS, because you can load iframe to google.com, and then you can just bypass same origin policy because it's in the same process, right? So you get JavaScript exploit or do some exploit that will compromise the process. You can do iframe to Google, and then now suddenly you have script execution in google.com, so you can steal all Google data. So this is true for like browser that doesn't have site isolation, like Mozilla, Safari, Firefox and Safari. So it's pretty bad. And yeah, so why does renderer process compromise matter? Why it's like JS bugs, CSS bugs, browser bugs, and they should fix it. So why should people care? So on average, there's 10 plus bugs in each release of Chrome that could compromise the render process. That means like every version you have 10 plus bug. Out of that, probably at least you have one exploit. You can make one exploit that can compromise render process, right? And on top of that, people actually don't need to find a bug. There's a thing called patch gapping because Chrome is open sourced. Whenever they commit the patch, people can see it, right? So you actually need to monitor the commit, check what's the bug ID, right? And then try to access bug ID. If it's restricted, it's a security issue. And then try to see what was the patch, and then analyze and make exploit, right? So there was actually people doing this, and they actually sell those end day, like 1 day, to people. And there's a blog post about it. People had like 15 plus days before patch for the exploit, render exploit. So this means like, like we should assume that attacker has capability to compromise render process at any time, basically. So site isolation try to prevent like UXSS and other things to happen by isolating process per site. So how they do that? They basically isolate process by scheme plus ETLD plus 1. So ETLD plus 1 is basically domain. So if you have scheme and domain that matches, then you can be in the same process. But if it doesn't match, then you can't be in the same process. That way you can, even if you do iframe, it will be hosted in the separate process. So even you compromise the process, you cannot access another process, right? But then still there's a problem that you can still load image. It seems like an image, but you can do something like, okay, you load google.com in image tag, because browser don't know that what is it, and they can't pass image on browser process. So they will send all data to render process to pass that image data to see if it's an image or not. But at that point, if render process was compromised, you can already read data of Google, right? So to prevent this, Chrome has a protection called cross-origin read blocking, where they try to see content type, and then based on the blacklist, they will not allow certain type of resource to go into cross-site render process. So like HTML, XML, JSON, PDF, zip file, those cannot get into cross-site render process unless there is CORS. Still, there is some caveats in site isolation. One, data URL inherits process from navigation initiator. What that means is if you have iframe with data URL, that still lives in the same process. So if you allow people to specify arbitrary data URL, you are allowing them to compromise render process, and thus they can read any data in that process. So if Google has data URL iframe, that means if you have JS exploit or any render exploit, you can read Google data. And file URL actually shares whole scheme as a site. And so like if you open one file, that file can access other file because all scheme is treated as one site. And co-op doesn't work in file URL because file URL doesn't have response header, right? It's a local file. So there's no way right now to see if it's a sensitive file. So Chrome is working on this, but it's pretty hard. So it will take some time to fix these features, kind of. So I made a WinDivG script to actually spoof origin and URL. This is to see, okay, if I can spoof origin and URL in the render process and try to trigger JavaScript APIs, I can still spoof IPCs, right? So if I can confuse a browser process in IPC that, okay, I'm a google.com, right? And then tell them to do something or leak something. And then maybe I can get some information if they don't check origin. Because browser process knows what renderer process is rendered in. So they have all origin in each renderer process. But if they don't check in the time of API call or IPC call, they might miss. So I started calling random API with spoofed origin. It turned out that there's a post message. So in post message IPC, you can see that there's one target origin and then there's source origin. So you could specify who I'm sending to and what origin I am in IPC. So you could basically spoof origin, and then you can say that I'm Google and I'm sending this data to google.com. So other side says, okay, this is coming from Google, right? And it also worked on the other side. If some origin was sending data, the same origin check only happened in the render process. So you could say I'm Google, and then you can receive data from Google. So I basically used Rob's bug, right? He explained about using post message to steal PDF file. You can, because it's a post message, cross-process post message, you can say, okay, in this case, I'm apple.com. Please give me this PDF content data. And then they will give me back Apple PDF data. It can be any site, right? Because I can say any origin. This was $3,000. Site isolation bypass 2 is a bit complicated. So there's an API called navigator.register protocol handler. What it does is, this I think Gmail uses this. Basically, if you want to register your website as a handler, you can do that for whitelisted schemes. So in case of Gmail, they want to be able to open mail to links in the Gmail, right? So they will say, if user clicks on mail to, forward it to this URL, which should be same origin. Yeah, so this is the restrictions. Like you have whitelisted scheme, destination URL has to be same origin, and then user has to accept the prompt. So these are like, it's a pretty like powerful API, but you need so much things. So basically, it turned out that the whitelist was only in the render process. Browser process only had blacklist. So you could do like, I want to handle Skype scheme, I want to handle MS Word scheme, I want to handle anything that is not related to browser, and you could handle that request. Destination URL check was completely in the render process. So you could say, okay, please forward the request coming to this scheme to this site. And then user prompt, they were calculating origin from destination URL. And you already know that destination URL, you can set anything after render compromise. And if you set to data URL, because it's a null origin, they couldn't calculate the origin, so they can't show origin. So basically, they will say, wants to open email. And you could trigger this API from iframe, so people would not know, okay, who is calling this API, right? You could be advertisement, and you are calling from, trusted website, but inside advertisement, compromising render process and requesting for some protocol handler. Okay, so, but how can this be a site isolation bypass? Let's say you compromise the render process. You register any scheme like mail to, tell, that are commonly used, and then register data URL, this data URL as a destination URL, right? You need to find a web page that doesn't have X-frame option and has this scheme. So I think most of banks has like contact us page where they have tell link to their contact number or email. I hope some of them don't have X-frame option. So if they don't, you can actually do clickjacking on that page, right? When user clicks on that any target page with tell or mail to link or anything else, it will redirect to this fast data URL. As I explained. Again? So you have to click on the link, but you can clickjack if the target page doesn't have X-frame option, right? So after that, it will redirect from target page to data URL. So data URL will still be in the target process, right? And then you can compromise that process to get data. So I don't know if you got it. It's complicated, but this is how this works.
If there was like an open redirect in the website.
Yeah, that works by default. You shouldn't have open redirect to data URL. If you have it, it's a website bug. Basically, that's how site isolation considers. Yeah, and then site isolation bypass 3. So they have reader mode. Chrome has a reader mode. Disabled by default in desktop, enabled by default in mobile platforms. So they have this weird Chrome distiller scheme with GUID, and you have URL parameter where you are loading that page. So basically, it's a news, and then you want to read news without ads, right? So they allow image and videos, but GUID changes for every load. But the site isolation assumption here is that if you are able to load even image in a target site, the assumption is that you can compromise that process, because there's also a bug in image parser that can potentially compromise render process, right? So you can load image and video, and there was other bug which I can't talk. But yeah, so what can you do if you have render compromise in reader mode? So when you compromise process, because CSP is only applied on render process, you can bypass CSP. They had CSP, but you can bypass at that point. And then you can open victim page. I use Twitter message in the actual POC, right? Open the message using this JavaScript because you can already execute script after render compromise. And then now you redirect victim page with same GUID and that victim URL parameter, because it's already cached, they will load in the same GUID and same scheme. So now it becomes same origin. And then after that, you can steal data of cross-site page. And this was 5,000K. Oh, sorry. Sorry, I'm slept. 5K, sorry. Yeah. Yeah, but if you think about it, site isolation bypass is a bit difficult. Reader mode and protocol handler bug required user interaction, like you need to, a user has to accept the prompt. Reader mode, you have to use reader mode. Message and protocol handler wouldn't work on every website. You need to have post message in the website, and the protocol handler, you need to have mail to or tell or any link on the victim web page. But I need something like really nightmare, like UXSS by one call or something, and really easy to find. This is like really difficult to find. You need to go to source code and then spoof so many things, and it takes time. So let's think in this way, like, okay, what process has access to cross-site data by design? So I don't think this is a whole list, but I just noted what I know. So above 3 are privileged already. Browser and network process has medium IL, so it's unsandboxed. GPU process is low IL, so it's still sandboxed, but it's kind of EOP already. It's worse than site isolation bypass. DevTool process and Flash process, you need user interaction because DevTool you need to press F12, right? Kind of, because user have to press. You can't open DevTool. Flash, they need to accept Flash, right? So extension process is the thing only left. Probably they have extension that user installed, it's enabled by default, it's there. And from my point of view, it makes sense because these are all donations, right? This is only Google VRP. If you think about it, Google VRP has extension bug bounty, and it's not owned by Chrome. Yeah, so I will anyways choose the last one. So yeah, just so to explain about Chrome extension, basically usually extension has 2 things: background script and then content script. Background script runs on extension process, and then content script is injected into render process. Because like ad blocker, for example, ad blocker needs to block like ads on each page. So they need to inject script to block all ads. But this means even though it's in an isolated world, which means they have different V8 instance, they are in the same process. So if you compromise the process, you can suddenly call content script API, right? That is exposed. Okay, so what's in there? Basically, there is a way to communicate between content script and background script. These are not full list, but you can see that there's a send message, send request, post message, and Chrome storage, because it's synced between content script and background script. So I think this seems easy because I don't think extension developer knows about renderer process compromise first. Like I don't think they know it. Site isolation threat model assumes that render process is compromised, right? So I don't think developer knows this as well. And then content script can be fully compromised, so you can't trust any of those messages, where I think extension developer trusts. So let's check Google extensions. This is the URL where you go and then see all extension that is eligible for Google bug bounty. So yeah, this is a great extension because it's built by Chrome team. yeah, I can prove if I find bugs there, I can already prove that it doesn't work because Chrome team can't implement, right? And this extension was also privileged because it's whitelisted by Chrome browser. So it has access to like web store, it has access to DevTools, it has access to new tab page, which extension usually doesn't have access. So this was message listener in background script. So message is just a message that's coming, and this is like object. You can see target, action. You need to notice here that, okay, if target, right, if target is pref, you can actually, if action is set pref, you can set preference with your value, and then basically you can set any preference. Okay, so what can you do with setting preference? There was a preference called site-specific script loader, which basically allow you to specify JavaScript, and then that will be loaded in every page. So you could set a page, right? Set script after render compromise, and then you basically send this message, and this script will be loaded to every page. So this was your XSS. And there was another listener. This basically says, okay, there was a request coming. This is controllable, right? And then they look for source file, and then they try to do fetch code with source file, and then try to get callback, and this callback will go to here, which will go to content script. So what does fetch code do? They basically do get URL with actually like they get files here, and file is called here for each. They will each load each files in here, right? This is the function, and then they will get source. This is the file that you passed. You get extension dot, you call chrome.extension.get URL with this source, and then they will basically do XHR and then return this code, like this script text, and then return code to callback. So this will send to content script. Okay, so there was actually weird behavior in chrome.extension.get URL. So basically, there is two APIs, chrome.extension.get URL and chrome.runtime.get URL. Chrome.extension was duplicated, old API. So the main purpose of this API is to basically give a full pass of relative URL. So if you say bar.js, if your extension was foo, you will get this URL in the result. But if you give like HTTPS URL, in the runtime, they will provide like full pass with extension. But in the old API, they will just return back as is. So what you have to do was you compromise renderer, just send message with google.com, and then you can get content. That's it, right? It's a full site isolation bypass. Like you can get any content after render compromise. And it's long, sorry. And there was also another message call, chrome.tabs.create with destination, which was here, which was getting, they were getting from message URL. So you could control destination. And they do create, tab.create with this destination. Chrome.tabs.create can open any URL like Chrome URL or file URL. So it's privileged call. What can you do with it? Actually, you can do site isolation bypass because in Chrome, by default, you can download one file automatically without user interaction. So you can download this exploit file, right, from the remote website. Use this bug to open this URL. You need to get the username, but this is actually in the heap of the render process, so you can get from the heap, or even you can do brute force. Right, and once this local file is open, you can again compromise render process because it's your file, right? You can run exploit there again. Now you can include in local file iframe any file, and then you can steal any local file. This is like Chrome default directory where user cookies, local storage and disk cache of all like web page you visited. Cookie is encrypted, but in Linux, the key is hard-coded, so you can decrypt.
But you would have to guess their username, right?
No, so username is in the heap. So in the render process, they have, because they need to, I don't know, they load some local file or something, they already have information of your username inside the heap. So you can actually find heap information. I forgot the command, but you can already find in WinDBG after you attach to render process. And you can even brute force. It's not like complicated. It's in Windows. So the bug was you can open any page, which is like you can read any files, and you can even open Chrome settings, right? Fourth bug was basically they had 25 history loaded in each render process. So they have all your latest 25 visited history inside the render process, which means you don't even need a bug because you have Spectre type attack where you can read same process data, like because it's same process, right? It's already there, so you just need to find it. So you without a bug you can read user history, and it's not patched basically. After 3 months, I thought 90 days was disclosure, but yeah. So I don't know, maybe Chrome team can open it, or I should wait till they fix it. But yeah, and then they gave 5,000, which was okay, because there were so many bugs, UXSS, and you could read anything. Oh, okay, I have a video. I hope it plays, please. Can you see it? Yeah. So I will use DevTools because I don't have render exploits, sorry. So I assume that there was a script execution in the render compromise, and then you could basically execute any code in the render process. So I'm assuming that this is possible. So you call these APIs, and then you see that Google response was there, right? It's long, sorry. And yeah, it's too long. And you also see the square. It's because extension is working. Extension is trying to reading this content. This is basically screen reader extension. So that one actually opened Chrome settings, which you shouldn't be able to. And you can see all histories. And finally, there should be a UXSS. So once you load this content, you open new tab page. You have XSS in local new tab page. You could even load Chrome Store. You have XSS there as well. And then if you open DevTool, hopefully, there's XSS in DevTools as well. So yeah, it's like it's all gone, basically. Right. So this is so long. I will speed up. So there was RSS reader extension from Google again. They basically try to preview RSS data from somewhere. So if they see the response header is RSS/XML, they try to load preview in extension page. And their code was like this, basically. You can have your RSS data anything, and then they will try to load this title and description and do in HTML. There was CSP, so I couldn't do script execution. And this preview was loaded in data URL. So even after render compromise, you couldn't actually, even if you had script execution, you couldn't call extension API directory because it's not same origin. But data URL inherits same process. So after compromise, you can actually own the extension process. And in theory, it's only like script is only restricted. So you can use CSS, render a bug, or image, or video, audio, other bugs to compromise the render process. But we should try bypassing CSP, right? So in CSP, there's a rule that local schemes should inherit CSP from creator or navigation initiator. So local schemes are things like about, blob, data, JavaScript, those local schemes that are not remote, basically. But it doesn't make sense in case of source doc, right? In iframe source doc, if you try to get CSP from navigation initiator, right? So the first script, this yellow one, will get blocked. Of course, there's a CSP from parent, so it will be blocked. And it will be processing the meta refresh on the second one. It will go to attacker page, which will do history.back, which will load the previous same script. But this time, it was done by attacker.com, like or attacker site. So they will try to inherit CSP from attacker.com, which we don't set it. And script will now execute because there's no CSP anymore. So that was bypass in Chrome. So I got 3,000 for CSP bypass and something for XSS analysis. Yeah, so this is also not fixed. Please Google. Fix. It's more than 3 months. OK, so I can do ripe demo because I have 1 week old Chrome build. Hopefully, they didn't updated it. Oh, it's too small? I hope it works. Oh, it doesn't. No, I have video if it doesn't work. Oh, no. OK, that sucks.
Was it actually fixed? Or?
No, it's not fixed. Yeah, maybe network issue because I'm running in VM. Anyways, OK, I'll see the video. So what you needed to do was just open attacker page. They will automatically render attacker site and then do alert one, basically. That's it. And this is still in data URL, so you need renderer compromise. But as you can see, there is only extension process there, right? And network and browser process. So basically, you could own all extension process, which is really bad. You can still do CSP bypass is patched, but if you have like some CSS renderer compromise, then you can still exploit it. Go ahead. Or patch. Yeah, please patch. I cannot talk. I want to publish this talk. Yeah. Oh, sorry. Oh my God, it's too long. Yeah, OK, I'll go fast. So there's a user agent switcher from Chrome. For Chrome, but still from Google. You could basically set any UA with any string. And they wanted to also spoof each website JavaScript because website do like navigator.useragent. So you also need to spoof in case your extension spoof to other user agent. So they had to inject content script to every page to spoof. Right? So what they did was basically they took this string, added to a script, right? And this is XSS. So this is UXSS, basically. You can send this user agent with plus alert origin. They didn't have edge user agent, which I really hate. So that's why I added with a payload. And this is UXSS. So sometimes this could happen. Like you can send message to to extension process. There is no bug, but they might use some data that is passed to content script that is injected to every process, and you can do UXSS. Oh, it was 5,000. So maybe Google extension is only insecure extensions, right? Maybe Google employees only write insecure code. Yeah, or maybe we can check. So I checked some popular extension and extension that has bug bounty. So everything requires render compromise. I will only talk about POCs, no root cause, because it's too long. Yeah, LastPass, you could steal any password, basically. LastPass. It's not patched. Yeah, it's not patched. Please don't talk. They are actively working on fix for 2 months. Yeah. So don't talk, but yeah, you can steal. And they paid $100 because they said it's a defense in depth, right? It's not our bug, it's a Chrome bug. And we are doing defense in depth, which is OK. There was keeper security, other place. They actually saved the password, but they couldn't protect the credit card, so you could steal credit card. It's fixed, and they were really good. They are the only good third-party extension, like bug bounty program, which is really good. Like after I reported, they called me and then they understand, and yeah, it was really good. This is another password manager. You could steal password, credit card, anything, basically. Yeah. uBlock Origin, famous ad blocker. You could read content. You could open any URL. You could do UXSS, which is now fixed. And patch is also open source, so you can see it. Yeah, it's complicated, really. Like, you needed to write hidden user setting, and you need to write this text and save that, and then you try to write a filter with this filter. This basically tells that, okay, if you find this alert.js, which is coming from this one, try to include this in all render process, and then you try to reload all filters so that it will work on all render process. It's complicated, but not too complicated, maybe. And AdBlock, they haven't fixed. I don't want to talk because I don't know when they will fix. And there's 60 plus million users, right? Yeah, so I don't want to get sued. So, but yeah, this one, so I will talk about fixed bugs. So yeah, basically there was same bug, chrome.extension.getURL. They get URL from content script and they try to pass, so you can read content of cross-site. You could do XSS in get adblock because they had the content script where they try to get user ID and add it as an argument in the content script of adblock.com, getadblock.com, where you could just change the content and try to script. So, wait. But I will show you a video. There was another bug. They had DOM message listener, so normal window.add event listener in getadblock.com, which was fixed. They were basically receiving message and passing that message to extension page. So you could pass any message to extension page. And you can see some of the bug which is not fixed, which I'm not going to talk, but you can see what will happen. Right, this is my attacker page. You'll click, you'll have adblock.com. You see that this is adblock background page saying something from me. So this is executed in background page of adblock, which is not fixed. And you can open any page. So you can, this is site isolation bypass, which is not patched, affecting 60 plus million users, and they are working on it without any timeline. So I think extension needs more attention. I talked about render compromise, and I could even take over extension process sometime. So what can you do? Maybe you can do, maybe browser sandbox escape from extension API, because if you can compromise extension page, it has a lot more API than normal render page. That means you can try to call some API that has a memory corruption bug in browser process and try to escape sandbox that way. So I haven't seen any of those research, but maybe that's something you can do it. Another thing is extension has like web accessible JS files. So they can say their JS file is accessible to website, any website, and they can load it. If there is a script gadget in that website, you can basically bypass any CSP, because CSP by design can't block extension script. It's just by design, because extension script needs to inject, and browser doesn't block that. So even if you have like script source none, extension script will still be loaded. So if you have script gadgets, right, in that JS file, you can try to load HTML content with that will trigger that gadget and then bypass CSP that way. So maybe someone can work on that research. So for the extension developer, they need to validate that message sender actually comes from privileged Chrome extension page, because they are confused basically that who is sending this message. Sometime extension pop up and like option page sends this same message, but they don't know that content script can be compromised and they can send the same message. And the Chrome team actually did a nice post about renderer compromise and why a extension developer needs to care, so they have to read it. Also, what like most of the third-party extension were like, yeah, this is not our bug, but we are fixing just in case by defense in depth. I think like if password manager stores password plaintext, people will scream, right? Okay, why do you scream? Because sometimes server get compromised, but possibility of server getting compromised versus possibility of render process getting compromised is just, you know, like render process is too easy. Like you don't need to find a bug, you just need to see, right? You just need to see the patch. And you can get plain text of your password. So why does it, like, why do you not consider that as a bug, right? So conclusion is site isolation is really good. Now it's really getting difficult to bypass. Chrome team actually announced a site isolation bypass. So they pay up to 20K for these bugs. My bugs were all like before this bounty was announced. So probably you can get double. Yeah. So it's actually great from browser point of view, but extension is still missing. Yeah, so if you have extension installed, good luck. So I think we should move to origin isolation. Site isolation is good, but practically it's difficult. Like if like sometime you have XSS on some subdomain of Google, right? And then suddenly if you have render exploit, you can already read like Gmail content, which is ridiculous, right? Anyone can just have XSS in any subdomain of Google, and suddenly they can access Gmail because it's in the same site, because it's only separated by subdomain, and maybe it should be fixed. So I think next step is origin isolation, and also what to do about copy-paste. I actually tweeted about copy-paste. Because site isolation assume that even image can compromise render process. Many websites allows copy-paste of image, right? Like even Google Slide, if you copy-paste image, they will first try to load that URL. So you can, if you have, you know, good image parser bug, you can compromise that process. You can already read Gmail at the point, and everything is end. So slice, when you do copy paste, first they will try to load from the remote source, so any source like attacker page, and then they will try to change that image to PNG and then send that to a server, and then the server will then validate if it's a valid image or not. Meanwhile, so in meanwhile this is happening, they actually load attacker image first. Like Google Slide, right? Yeah. I don't know. I haven't checked Google Docs, but Google Slide is in Google Docs, so that's the end. Basically, yeah. Okay, but yeah, but I saw the slides and it was already vulnerable. So like, Stefan did good research about you know, network socket exhaustion. So you can basically block all network sockets so that your copy paste will just paste the image and it will stay there, because you cannot request your converted image to server, and that way your image will be loaded there and you can compromise. So site isolation team probably needs to think, okay, what should we do next about copy paste, because it's kind of weird. Yeah. And thanks to the Google VRP site isolation team, I work with them. And Rob, yeah, Rob created great website and also extension. You can use his website to read extension code without downloading extension. So it's really great to use his tool for all extension pen testing. And Edge also has bug bounty. Please report. We already had 2 XSS in new tab page. We paid 15K each, right? So if you are finding like accounts.google.com and getting, yeah, 7.5K, maybe you get double. Yeah. Right. Any question? Yeah, this was another extension bug without render compromise. You could inject CSS in color enhance, some Google extension basically. This was 2,000, 3,000 something. Yeah. Yeah. I think everyone can come. It's QA for everyone, right? Yeah. All Chrome people like who presented, Rob and. Yeah, if anyone has any. Thanks. Sorry for the long talk.
That's quite interesting.
Oh, thank you. Yeah, anyone? Question?
One question for you.
Yeah.
So you mentioned about extensions with gadgets and bypassing the CSP. Why do you consider that to be interesting?
So, because let's say if AdBlock has this gadget script, right? It's installed in 60 plus million people, and you can bypass any CSP. So if you have injection point where you can do script, right? You can inject the script with source of that content. You can basically bypass CSP. You don't. It doesn't matter what CSP it is. You can bypass. It's by design. So I don't think people like Masato did really great write up about this in Mozilla. If you know, like he found a script gadget in Mozilla resource. So Mozilla actually hosted that vulnerable JavaScript, and he was able to bypass CSP universally. So I'm hoping for that thing in normal extension.
Yes, those exist. So Mozilla has an add-ons linter which maintains libraries of vulnerable libraries. Those libraries are blocked from AMO, so when the user uploads extension to add-on to Mozilla.org that has such a vulnerable library, that is blocked. So you could use this database to scan Chrome Web Store or the Edge Gallery.
Hopefully. Yeah, because it was there. It was there in Mozilla, like Mozilla source code. So yeah, maybe it works. Yeah, it's research from Eduardo, right? Script Gadgets was research from them. And it was really great. And we only know old script that is found by them. We don't know any other scripts. So if people find new gadgets, it's suddenly bannable. Yeah. So I think it's interesting for research.
Yeah, Chrome and Edge are more vulnerable than Firefox in this regard because extensions have a fixed host name in Edge and Chromium-based browsers.
Like Chrome/extension?
Yes, Chrome extension and then the 32 character.
Yeah. I think when you have web accessible, you can by design access. So yeah, I think it's by design. Maybe Mozilla don't do it. Yeah, but yeah, it's our choice. It's Chrome's choice. Anything?
Any questions for the other Chrome speakers? Yuri and who was before Yuri? Or after Yuri? I forgot.
No.
Oh, Luan, where are you? Questions for Luan or Yuri? All right.
Right. Thank you.
Awesome. Thank you very much. Yay.